Hello, in the last video we studied how to convert a decimal number system to a binary number system, and we took some examples. In this video we will take more examples to understand the idea very well. Example 1. Convert the decimal number 0.125 to binary number. To convert fractional number from decimal to binary, multiply the number with 2 until the number finally becomes 0, or stop after required decimal places. Traverse the integers from top to bottom to get the result number in binary. We will make two columns, fraction and integer. Multiply the number 0.125 by the base 2 equal to 0.25, so the integer part is 0 and the fractional part is 0.25. Then multiply the number 0.25 by the base 2 equal to 0.5. So the integer part is 0 and the fractional part is 0.5. Then multiply the number 0.5 by the base 2 equal to 1. So the integer part is 1 and the fractional part is 0. Traverse the integer column from top to bottom. So the number 0.125 in decimal is equal to 0.001 in binary. Let us take another example. Example 2. Convert the decimal number 36.57 to a binary number. For convenience, we will take the number as two parts, the integer part and the fractional part. Then we add the two converted parts together. First, we will convert the integer part of the number, which is 36. We will make two columns, integer and remainder. Divide 36 by the base 2 gives 18, with a remainder 0. Then divide 18 by the base 2 gives 9, with a remainder 0. Divide 9 by 2 gives 4 with a remainder 1. Divide 4 by 2 gives 2 with a remainder 0. Then divide 2 by 2 gives 1 with a remainder 0. Then divide 1 by 2 gives 0 with a remainder 1. Now traverse the remainder column from bottom to top. So the number 36 in decimal is equal to 100,100 in binary. Now we will convert the fractional part of the number, which is 0.57. We will make two columns, fraction and integer. Multiply the number 0.57 by the base 2 equal to 1.14. So the integer part is 1 and the fractional part is 0.14. Then multiply the number 0.14 by the base 2 equal to 0.28. So the integer part is 0 and the fractional part is 0.28. Multiply the number 0.28 by the base 2 equal to 0.56. So the integer part is 0 and the fractional part is 0.56. Multiply the number 0.56 by the base 2 equal to 1.12. So the integer part is 1 and the fractional part is 12. Multiply the number 0.12 by the base 2 equal to 0.24. So the integer part is 0 and the fractional part is 0.24. Multiply the number 0.24 by the base 2 equal to 0.48. So the integer part is 0 and the fractional part is 0.48. Multiply the number 0.48 by the base 2 equal to 0.96. So the integer part is 0 and the fractional part is 0.96. Then multiply the number 0.96 by the base 2 equal to 1.92. So the integer part is 1 and the fractional part is 0.92. Stopping at 8 decimal places. Traverse the integer column from top to bottom. So the number 0.57 in decimal is equal to 0.1001001 in binary. Now we add the two converted parts together. The converted integer of 36 was 100,100 plus the converted fractional, which is 0.1001001. This is equal to 100,100.10001. So the number 36.57 in decimal is equal to 100,100.10001 in binary. Let us take another example. Example 3. Convert the decimal number 37950.5071 to a binary number. This is a big number, so we will solve it using the LogicKit app and get the solution with very well explained step by step. Go to the App Store, search for LogicKit, open the app, go to the Convert Numbers section, select the input base 10, select the output base 2, type the number 37950.5071. As we can see, the app gives us instantly the result in binary. Now let us see the step-by-step solution. As you can see, everything is explained, and you can follow the step by step to understand the solution. I will leave the link to download the Logic Kit app from the App Store in the description. Don't forget to subscribe to the channel and follow us on Facebook and visit our website. All links are in the description.